At one point, Goodman remarks correctly that even though for certain remarkable facts I have no alternative explanation, that alone does not dictate acceptance of whatever theory may be offered, for the theory might be worse than none. Inability to explain a fact does not condemn me to accept an intrinsically repugnant and incomprehensible theory. But now consider the theory of innate ideas that Goodman regards as intrinsically repugnant and incomprehensible. Notice first that the theory is obviously not incomprehensible on his terms. Thus, he appears to be willing in this article to accept the view that, in some sense, the mature mind contains ideas. It is obviously not incomprehensible, then, that some of these ideas are implanted in the mind as original equipment, to use his phraseology. And if we turn to the actual doctrine as developed in rationalist philosophy, rather than Locke's caricature, the theory becomes even more obviously comprehensible. There is nothing incomprehensible in the view that stimulation provides the occasion for the mind to apply certain innate interpretive principles, certain concepts that proceed from the power of understanding itself, from the faculty of thinking, rather than from external objects directly. To take an example from Descartes, his reply to Objections 5, quote, when in infancy we see a triangular figure depicted on paper, this figure cannot show us how a real triangle ought to be conceived, in the way in which geometricians consider it, because the true triangle is contained in this figure, just as the statue of Mercury is contained in a rough block of wood, but because we already possess within us the idea of a true triangle, and it can be more easily conceived by our mind than the more complex figure of the triangle drawn on paper, we therefore, when we see the composite figure, apprehend not it itself, but rather the authentic triangle. And you can see Descartes' philosophical works. In this sense, the idea of a triangle is innate. Surely the notion is comprehensible. There would be no difficulty, for example, in programming a computer to react to stimuli along these lines, though this would not satisfy Descartes for other reasons. Similarly, there is no difficulty in principle in programming a computer with a schismatism that sharply restricts the form of a generative grammar, with an evaluation procedure for grammars of the given form, with a technique for determining whether given data are compatible with a grammar of the given form, with a fixed substructure of entities such as distinctive features, rules, and principles, and so on. In short, with a universal grammar of the sort that has been proposed in recent years. For reasons that I have already mentioned, I believe that these proposals can be properly regarded as a further development of classical rationalist doctrine, as an elaboration of some of its main ideas regarding language and mind. Of course, such a theory will be repugnant to one who accepts empiricist doctrine and regards it as immune to or question or challenge. It seems to me that this is the heart of the matter. Putnam's paper deals more directly with the points at issue, but it seems to me that his arguments are also inconclusive because of certain incorrect assumptions that he makes about the nature of the acquired grammars. Putnam assumes on the level of phonetics the only property proposed in a universal grammar is that a language has a short list of phonemes. This, he argues, is not a similarity among languages that requires elaborate explanatory hypotheses. The conclusion is correct, the assumption is quite wrong. In fact, as I have now pointed out several times, very strong empirical hypotheses have been proposed regarding the specific choice of universal features, conditions on the form and organization of phonological rules, conditions on rule application, and so on. If these proposals are correct or near correct, then similarities among languages at the level of sound structure are indeed remarkable and cannot be accounted for simply by assumptions about memory capacity, as Putnam suggests. Above the level of sound structure, Putnam assumes that the only significant properties of language are that they have proper names, that the grammar contains a phrase structure component, and that there are rules abbreviating sentences generated by the phrase structure component. He argues that the nature of the phrase structure component is determined by the existence of proper names, that the existence of a phrase structure component is explained by the fact that all the natural measures of complexity of an algorithm, size of the machine table, length of computations, time and space required for the computation, lead to the result that phrase structure systems provide the algorithms which are simplest for virtually any computing system, hence also for naturally evolved computing systems, and that there is nothing surprising in the fact that languages contain rules of abbreviation. Each of the three conclusions involves a false assumption. From the fact that a phrase structure system contains proper names, one can conclude almost nothing about its other categories. In fact, there is much dispute at the moment about the general properties of the underlying phrase structure system for natural languages. The dispute is not in the least resolved by the existence of proper names. As to the second point, it is simply untrue that all measures of complexity and speed of computation lead to phrase structure rules as the simplest possible algorithm. The only existing results that have even indirectly relevant show that context-free phrase structure grammars, a reasonable model for rules generating deep structures when we exclude the lexical items and the distributional conditions they meet. When we exclude the lexical items and the distributional conditions they meet, receive an automata theoretic interpretation as non-deterministic push-down storage automata. But the latter is a hardly natural notion from the point of view of simplicity of algorithms and so forth. In fact, it can be argued that the somewhat similar but not formally related concept of real-time deterministic automation is far more natural in terms of time and space conditions on computation. For some discussions of these matters, see Formal Properties on Grammar in the Handbook of Mathematical Psychology. For more extensive discussion on the automata theoretic framework, see R.J. Nelson, Introduction to Automata. A detailed presentation of properties of context-free grammars is given in S. Ginsburg, The Mathematical Theory of Context-Free Languages, and there have been a number of studies of speed of computation, simplicity of algorithms, and so on, but none of them has any bearings on the issue under discussion here. However, it is pointless to pursue this topic because what is at stake is not the simplicity of phrase structure grammars, but rather the transformational grammars with a phrase structure component that plays a role in generating deep structures. And there is absolutely no mathematical concept of ease of computation or simplicity of algorithm that even vaguely suggests that such systems may have some advantage over the kinds of automata that have been seriously investigated from this point of view. For example, finite state automata, linear bounded automata, and so on. The basic concept of structure-dependent operation has never been considered in a strictly mathematical concept. The source of this confusion is a misconception on Putnam's part as to the nature of grammatical transformations. They are not rules that abbreviate sentences, rather they are operations that form surface structures from underlying deep structures in such ways as are illustrated in the preceding lecture and their references there cited. Hence, to show that the transformational grammars are the simplest possible, one would have to demonstrate that the optimal computing system would take a string of symbols as input and determine its surface structure, its underlying deep structure, and the sequence of transformational operations that relates them. Nothing of the sort has been shown. In fact, the question has never even been raised. Putnam argues that even if significant uniformities among languages were to be discovered, there would be a simpler explanation than the hypothesis of an innate universal grammar, namely their common origin. But this proposal involves a serious misunderstanding of the problem at issue. The grammar of a language must be discovered by the child from the data presented to him or her. As noted earlier, the empirical problem is to find a hypothesis about initial structure rich enough to account for the fact that a specific grammar is constructed by the child, but not so rich as to be falsified by the known diversity of language. Questions of common origin are of political relevance to this empirical issue in only one respect: if the existing languages are not a fair example of the possible languages that we may be led mistakenly to propose too narrow a schema for universal grammar. However, as I mentioned earlier, the empirical problem that we face now is that no one has been able to devise an initial hypothesis rich enough to account for the acquisition by the child of the grammar that we are apparently led to attribute to him or her when we try to account for his or her ability to use the language in a normal way. The assumption of common origin contributes nothing to the explanation of how this achievement is possible. In short, the language is reinvented each time it is learned, and the empirical problem to be faced by the theory of learning is now how this invention of grammar can take place. Putnam does face this problem and suggests that there might be general multi-purpose learning strategies that account for this achievement. It is, of course, an empirical question whether the properties of the language faculty are specific to language or are merely a particular case of much more general mental faculties or learning strategies. This is a problem that has been discussed earlier in this lecture, inconclusively and in a slightly different context. Putnam takes for granted that It is only general learning strategies that are innate, but suggests no grounds for this empirical assumption. And as I have argued, a non-dogmatic approach to this problem can be pursued without reliance on unargued assumptions of this sort, that is, through the investigation of specific areas of human competence, such as language, followed by the attempt to devise a hypothesis that will account for the development of this competence. If we discover through such investigation that the same learning strategies are sufficient to account for the development of competence in various domains, we will have a reason to believe that Putnam's assumption is correct. If we discover that the postulated innate structures differ from case to case, the only rational conclusion would be that a model of mind must involve separate faculties with unique or partially unique properties. I cannot see how anyone can resolutely insist on one or the other conclusion in the light of the evidence now available. But one thing is quite clear. Putnam has no justification for his final conclusion that invoking innateness only postpones the problem of learning. It does not solve it. Invoking an innate representation of universal grammar does not solve the problem of learning. If it is true that this is the basis for language acquisition, as it well may be, if, on the other hand, there are general learning strategies that account for the acquisition of grammatical knowledge, then postulation of an innate and universal grammar will not postpone the problem of learning, but will rather offer an incorrect solution to this problem. The issue is an empirical one of truth or falsity, not a methodological one of states of investigation. It is surprising to see that Putnam refers despairingly to vague talk of classes of hypotheses and weighing functions in the course of his discussion of general learning strategies. For the moment, the latter is a mere phrase without any describable content. On the other hand, there is a substantial literature detailing the properties of the classes of hypotheses and weighting functions to which Putnam refers. Hence, the shoe seems to be on the other foot in this case. To summarize, it seems to me that neither Goodman nor Putnam offers a serious counter-argument to the proposals concerning innate mental structure that have been advanced, tentatively, of course, as befits empirical hypotheses, or suggest a plausible alternative approach with empirical content to the problem of acquisition of knowledge. Assuming the rough accuracy of conclusions that seem tenable today, it is reasonable to suppose that a generative grammar is a system of many hundreds of rules of several different types, organized in accordance with certain fixed principles of ordering and applicability, and containing a certain fixed substructure, which, along with the general principles of organization, is common to all languages. Again, it is reasonable to suppose that a generative grammar is a system of many hundreds of rules of several different types, organized in accordance with certain fixed principles of ordering and applicability, and containing a certain fixed substructure, which, along with the general principles of organization, is common to all languages. There is no a priori naturalness to such a system, any more than there is to the detailed structure of the visual cortex. No one who has given any serious thought to the problem of formalizing inductive procedures or heuristic methods is likely to set much store by the hope that such a system as a generative grammar can be constructed by methods of any generality. To my knowledge, the only substantive proposal to deal with the problem of acquisition of knowledge of language is the rationalist conception that I have outlined. To repeat, suppose that we assign to the mind as an innate property the general theory of language that we have called universal grammar. This theory encompasses the principles that I discussed in the preceding lecture and many others of the same, and it specifies in certain subsystem of rules that provides a skeletal structure for any language and a variety of conditions, formal and substantive, that any further elaboration of the grammar must meet. The theory of universal grammar then provides a schema to which any particular grammar must conform. Suppose, furthermore, that we can make this schema sufficiently restrictive so that very few possible grammars conforming to the schema will be consistent with the meager and degenerate data actually available to the language learner. His task then is to search among the possible grammars and select one that is not definitely rejected by the data available to him. And what faces the language learner under these assumptions is not the impossible task of inventing a highly abstract and intricately structured theory on the basis of degenerate data, but rather the much more manageable task of determining whether these data belong to one or another of a fairly restricted set of potential languages. The task of the psychologist then divided into several subtasks. The first is to discover the innate schema that characterizes the class of potential languages that defines the essence of human language. This subtask falls to the branch of human psychology known as linguistics. It is the problem of traditional universal grammar of contemporary linguistic theory. The second subtask is the detailed study of the actual character of the stimulation and the organism environment interaction that sets the innate cognitive mechanism into operation. This is a study now being undertaken by a few psychologists, and it is particularly active right here in California. It has already led to interesting and suggestive conclusions. One might hope that such study will reveal a succession of maturational stages leading finally to a full generative grammar. It is not unlikely that detailed investigation of this sort will show that the conception of universal grammar as an innate schematism is only valid as a first approximation, that in fact an innate schematism of a more general sort permits the formulation of tentative grammars, which themselves determine how later evidence is to be interpreted, leading to the postulation of richer grammars and so on. I have so far been discussing language acquisition on the obviously false assumption that it is an instantaneous process. There are many interesting questions that arise when we consider how the process extends in time. For some discussion relating to problems of phonology, see the paper Phonology and Reading in H. Levin, edited by in Basic Studies on Reading. Note also that it is unnecessary to suppose, even in the first approximation, that very few possible grammars conforming to the schema will be available to the language learner. It is enough to suppose that the possible grammars consistent with the data will be scattered in terms of an evaluation procedure. A third task is that of determining just what it means for a hypothesis about the generative grammar of a language to be consistent with the data of sense. Notice that it is a great oversimplification to suppose that a child must discover a generative grammar that accounts for all the linguistic data that has been presented to him or her, and that projects such data to an infinite range of potential sound-meaning relations. In addition to achieving this, he must also differentiate the data of sense into those utterances that give direct evidence as to the character of the underlying grammar, and those that must be rejected by the hypothesis he selects as ill-formed, deviant, fragmentary, and so on. Clearly, everyone succeeds in carrying out this task of differentiation. We all know with intolerable limits of consistency, which sentences are well-formed and literally interpretable, and which must be interpreted as metaphorical, fragmentary, and deviant along many possible dimensions. I doubt that it has been fully appreciated to what extent this complicates the problem of accounting for language acquisition. Formally speaking, the learner must select a hypothesis regarding the language to which he or she is exposed that rejects a good part of the data on which this hypothesis must rest. Again, it is reasonable to suppose this is possible only if the range of tenable hypotheses is quite limited, if the innate schema of universal grammar is highly restrictive. The third subtask then is to study what we might think of as the problem of confirmation. In this context, the problem of what relation must hold between a potential grammar and a set of data for this grammar to be confirmed as the actual theory of the language in question. I have been describing the problem of acquisition of knowledge of language in terms that are more familiar in the epistemological than a psychological context, but I think that this is quite appropriate. Formally speaking, acquisition of common sense knowledge, or knowledge of a language, for example, is not unlike theory construction of the most abstract sort. Speculating about the future development of the subject, it seems to me not unlikely for the reasons I have mentioned that learning theory will progress by establishing the innately determined set of possible hypotheses from this set and fixing the conditions under which such a hypothesis is confirmed, and perhaps under which much of the data is rejected as irrelevant for one reason or another. Such a way of describing the situation should not be too surprising to those familiar with the history of psychology, where, after all, Edward Tolman, for example, has given his name to the psychology building. But I want to stress that the hypotheses that I am discussing are qualitatively different in complexity and intricacy from anything that was considered in the classical discussions of learning. And as I have now emphasized several times, there seems to be little useful analogy between the theory of grammar that a person has internalized and that provides the basis for his or her normal creative use of language, and any other cognitive system that has so far been isolated and described. Similarly, there is little useful analogy between the schema of universal grammar that we must, I believe, assign to the mind as an innate character and any other known system of mental organization. It is quite possible that the lack of analogy testifies to our ignorance of other aspects of mental function, rather than to the absolute uniqueness of a linguistic structure. But the fact is that we have, for the moment, no objective reason for supposing this to be true. The way in which I have been describing acquisition of knowledge of language calls to mind a very interesting and rather neglected lecture given by Charles Sanders Peirce more than 50 years ago, in which he developed some rather similar notions about acquisition of knowledge in general. See C.S. Peirce's The Logic of Abduction in Peirce's Essays in the Philosophy of Science. And so, Peirce argued that the general limits of human intelligence are much more narrow than might be suggested by romantic assumptions about the limitless perfectibility of humans, or for that matter, than are suggested by his own pragmaticist conceptions of the course of scientific progress in his better-known philosophical studies. He held that innate limitations on admissible hypotheses are a precondition for successful theory construction, and that the guessing instinct that provides hypotheses makes use of inductive procedures only for corrective action. Peirce also maintained in this lecture that the history of early science shows that something approximating a correct theory was discovered with remarkable ease and rapidity on the basis of highly inadequate data. As soon as certain problems were faced, he noted how few were the guesses that men of surpassing genius had to make before they rightly guessed the laws of nature, and he asked how that it is that man was ever led to entertain that true theory. You cannot say that it happened by chance, because the chances are too overwhelmingly against the single true theory in the 20 or 30,000 years during which man has been a thinking animal, if ever having come into any man's head. A fortiori, the chances are even more overwhelmingly against the true theory of each language ever having come into the head of every 4-year-old child. Continuing with Peirce, quote, man's mind is a natural adaptation to imagining correct theories of some kinds. If man had not the gift of a mind adapted to his requirements, he could not have acquired any knowledge, end quote. Correspondingly, in our present case, it seems that knowledge of language, a grammar, can be acquired only by an organism that is preset with a severe restriction on the form of grammar. This innate restriction is a precondition in the Kantian sense for linguistic experience, and it appears to be the critical factor in determining the course of and results of language learning. The child cannot know at birth which language he or she is to learn, but they must know that its grammar must be of a predetermined form that excludes many imaginable languages. Having selected a permissible hypothesis, he can use inductive evidence for corrective action, confirming or disconfirming his choice. Once the hypothesis is sufficiently well confirmed, the child knows the language defined by this hypothesis. Consequently, his knowledge extends enormously beyond his experience, and in fact leads him to characterize much of the data of experience as defective and deviant.